So I want to start off just by taking a look at the following. So we have the Ebbinghaus forgetting curve, which is what we used as our phenomena in class today. And so I want to call out a couple of things. So the forgetting curve represents the normal pattern of forgetting for new information. And generally we forget about 60% of what we have just processed within the first 20 minutes. And it's intriguing to me to take a look at the fact that more than half of the memory loss that occurs is within the first hour, and that most of the material that will be forgotten is done so within the first 8 hours, and then we have this tendency to steady out. So if we're thinking about this in terms of just how we learn in a classroom environment, when we're studying, when we're trying to make sense of material, then we probably have to do something with, right, this forgetting curve. And so if we think about it, right, what's in the green is the forgetting curve that Ebbinghaus just talked about. So he was a researcher. This is his predicted model, right? So if, right, this is us, right, just normally, right, this is what we experience on a day-to-day basis. This is what we really want to achieve, right? Right? If we review immediately after class, and right, if we take steps to ensure our recollection, then we can address this curve, right? And ideally, we can actually beat these two curves if we do a couple of key things. If we review after class, if we have more than 5 or at least 5 instances of recall. So here's the big idea, right? Ebbinghaus is, this is our normal state. This is what we do if we just go to class, right? But what happens if we review immediately after class, and then if we review 24 hours later, and then if we review a week later, and then if we review a month later? So those 4 reviews show us how much less we'll forget if we're intentional about the way that we review. So here's the challenge, and I think this is something that's really important just for us to address. Much of college life is about being accountable for the ideas that you learn as a student. Part of that is the ability to retain and recall information when you need it. Some of that is making sense of that information. So, taking notes matters. I've given you a couple of options. You can use the light bulb sheets if that's helpful for you. If you have your own note-taking system, that's important too. But regardless of whether it's a lecture or a chapter from the textbook or something that you're reading, it's really important to have something that you can access as information to go back and review. The second thing is we really want to review right after class. So for those of you who have been staying from the 11:30 to 12 period on Mondays, that's brilliant. Please continue to do so. That makes such a big difference. The second thing is we really want to make sure that you try to review within at least an hour, right, or at least 24 hours. You can do that in Google Docs. You can do that in lots of different ways where you can access the information. But then you also want to make sure that you're reviewing 1 week later and a few weeks to a month later. If you do that, you're going to be much better able to access that information. So that's the first thing that I want to tackle just in terms of making sure that we're reviewing correctly. The next thing that I want us to think about, right, is the following. So one of the things that, oh, here we go. I can find it. I know I can. There we go. Okay. So one of the things that we talked about in class, right, was this phenomena. So that was our recall. We talked about why we forget. And so hopefully you have a couple of resources that allow you to address now this remembering and forgetting piece. And we'll practice with more of that shortly. The other thing we talked about in class today are the science practices and examples of each. So asking questions and defining problems. So for me, what didn't I remember from class? That's a great question to ask. Analyzing and interpreting data, well, we use that Ebbinghaus graph to understand recall. Constructing explanations, designing solutions, right? So that's proposing 5 strategies to improve recall. One of those we're going to use today is the think aloud. That's just where I'm going to talk through the information as I see it to try and make sense of it out loud. And then engaging in an argument from evidence, that's evaluating the strategies for you to determine what works. So if we take a look at the notes, right, here's mass percent, and this is where we kind of left off. last class. We took a look at calculating the molar mass of an element and then the molar mass of an entire compound. So we did this for copper, right, where it was Cu2S, so 2 times 63.55 grams per mole, divided by that mass plus the mass of sulfur. So if I wanted to know how much copper was in sulfur, I could do that calculation, multiply it by 100, and I have 79.85% copper by mass. Well, what if someone just gave us an amount of that material? They said 1.3 kilograms. I don't know how much copper is there. Well, then this ratio of 79.85 divided by 100 would be a conversion ratio that I could use to obtain the amount of copper. So that's where we started with mass percent. But we weren't quite done. One of the other things we needed to do was determine this process for finding empirical formulas. So if you'll recall, there are 4 steps, right? Are we already in grams? If not, convert the percent to mass. An example of that is shown here. Number 2 is converting the mass to moles. We're going to need our molar mass. We're going to have to get that from a periodic table. And then step 3 is to divide each amount of moles by the smallest amount of moles, right? And then the last one is multiplying by a common factor. So that's super important for us, is those 4 steps. So I've shown you step 1 here, right, where I'm converting my percentages to grams. Notice the numbers don't change. I'm literally writing, instead of percent, grams. That's because I'm assuming that I have 100 grams. Here, you already know how to do this calculation. If you know the amount in terms of grams and you divide by the molar mass, then you can obtain the amount of moles. We always use moles because that tells us the amount of a given element that we're using. Step 3 is where we're looking at our ratio. So here we take each of our molar amounts and we divide each of our amounts in moles, sorry, not molar, each of our amounts in moles, and we divide by the smallest amount in moles. That's going to give us these numbers. And you're going to recall that we have this notation here. If the result is within 0.1 of the whole number, then we can round. If not, then we have to multiply by a common factor. And that's what we've done here. If we multiply by 4, then each of these becomes a whole number. So C9H8O4 is the empirical formula for aspirin. So this is an example of that. I gave you 2 other examples that you could work through. So the answer for the first is Cu2O. The answer for the second is CH2O. And you can think about working through each one of these steps. I've shown those here. Right? And that should allow you at least a couple of examples to work with. We also talked about using the molar mass to find molecular formulas. From there, you're going to use your empirical formula and calculate a molar mass. And then either you're given or you're going to need to find the molar mass of your molecular formula. And if you use this expression, right, it's molar mass of the molecular formula divided by molar mass of your empirical formula, and that's going to give you a multiplying factor. In this case, the multiplying factor is 2. So I take my empirical formula and multiply it by 2, and that gives me the molecular formula, C2H4O2. The example that we worked through in class was BH3. So we figured out the molar mass of the empirical formula, and the problem gave us the molar mass of the molecular formula. And so using our expression, we were able to divide the molar mass of the molecular formula by the molar mass of the empirical formula, and that gives us 2. So our molecular formula is B2H6. Now we talked about 2 different ways that we could prepare solutions. Right? The first is that we weigh or measure out the solute. We add the solvent until the solute is dissolved, and then we add solvent until we hit the volumetric mark. The other way is to actually measure a known concentration, or a stock solution, and then dilute with the solvent until a total volume. So in order to do that, we have to pay attention to a couple of terms. Those terms are our initial concentration and our initial volume, as well as our final concentration and our final volume. Note here, concentration is the same meaning as the word molarity. We also sometimes use the word molar, or M-O-L-A-R, which means moles per liter. And so you can represent this equation as C1V1 equals C2V2, or you can use capital M1 V1 or capital M2 V2, which means the same thing. So this is in molarity, this in terms of concentration. And we had two examples. We said the most important thing to do was to figure out what our givens were, and then to plug our givens into our expression, and then we have to do some algebraic manipulation. Notice you can use your units to really help you out here. So for example, 1.6 moles per liter times liters, right? That gives me moles. And then if I divide both sides by liters, I'm now back to moles per liter, which is the unit that I need for concentration. And so I know that I'm on the right track with my calculation. You can do the same thing here. Here our unknown is C1. So moles per liter, right, is going to, right, the liters are going to cancel. I'm left with moles. If I divide both sides by liters, right, then I'm left with moles per liter, which again is C1, which is what I'm looking for. And in this case, I know that I'm on the right track in terms of my calculation. So that's a recap of the problems that we solved today in class. You'll have the opportunity to practice doing this both in your lab and in your discussion sections. Just keep in mind that you're going to have a quiz on this on Wednesday. Thanks again.